Hello, good afternoon to all of you. I hope all of you are doing well. So, in today's class, we are going to learn about the third instance in which what we cannot do is we cannot overload function. So, here just see in this two declaration we have the declaration for function add. Both are capable of returning integer value. In the first case, you are passing reference that is asterisk ptr. In the second case, you are passing a reference to an array that is you are using a notion for the array. But in both the cases, what you're doing is you're passing a reference to an integer value. In this case, also you're passing a reference to integer value. In this case, also you're passing an integer reference to an integer value because whenever you pass a pointer to an array, it will point to an integer value that is the beginning of the array, the first element of the array. So in both the cases, since you're passing pointer, so you're not allowed to have such kind of declaration. And whenever you run this particular program, the program will say that you'll have multiple definition for the same function because in both the cases you're passing pointers. So this is one important example of how the place where what you cannot do is you cannot overload function. Now let us talk about function overloading with the help of a few examples. So here I have function add that has multiple instances where in the first case we pass in two parameter integer parameter, in the second case we pass in three integer parameter, in the third case you pass in two integer parameter, then you passing double, two double, then three double parameters, then four double parameters. You see, just see what we are doing is we are trying to just make you understand that the way how function overloading basically works. So here what I have is I have multiple instances of add where number of parameters are different and the number and the type of parameters are different, right? Are you? So whenever I call a function by passing two integer parameter, so it will call this instance of add, right? Okay, so just see here I've defined add, and add that defines that adds two number and returns an integer. So whenever I call the function add by passing 5, 6 and 7, then it will call a function instance of add that adds three integer value, so it will return the sum of three number. So when I pass four integer value, it will call the function that adds four integer value and returns an integer, right? So when I pass two floating point number, just see 5.6 and 6.6. Now this will call a function that takes in two floating point numbers. So here there is a function that takes in two floating point number, that is double add, double x and double y. Now here why we are writing double instead of x, because double one case is double is a version of float, but in case of C++, there is a typical problem that is called as type conversion, where all the floating point constants, right? All the floating point constants are by default converted into type double. Okay, so you need to always remember in case of C++, there is a problem that is called as type conversion, where the floating point constants are converted into type double. So that's why what I have is I have a function that is that takes in two double variables and returns a double, right? Because of type conversion. So if you want to avoid that, then what I can do is I can declare two variable of type float x and y, and then to x I can assign 5.5 and to y I can assign 6.6, and then x and y can be passed to this particular add. Then what I can have is I can have float and float being, so float x and float y being placed here. So in order to, because of the problem of type conversion, floating point constants are automatically type converted to double. So for making the function work, what we need to have is we need to have the parameter type and the return type double. So here I'm passing two floating point numbers, so it will call this particular instance of add. Here I'm passing three floating point number, so it will call this instance of add. Here I'm passing four floating point number, so it will call this instance of add. So just see, depending upon the type and the number of, depending upon the type and number of the parameters, the the appropriate function definition will be called, right? So this particular property is called as a function overloading, where we have multiple instances of function by the same name, which differs in the parameter list and the number of parameters. Now let us discuss another program that is for structure. So here, yeah, as you all know, you must have implemented structures in C, but let's try to understand it again. So here, person is a structure which has a member name, age, and salary. So the default member of the default access specifier for structure will be public, as we have discussed in the theory class. So here I have a function that's called as display, which takes in a variable of type person, where person is a structure. So I've declared an object of type object P of type person. So now what I'm doing is I'm reading values into that particular. I am reading values into the individual members of the structure variables, right? Again, and then I'm displaying the content of the structure variable. So now what I have done is I have defined the function this as well. So this will display the attributes of the structure variable. So this particular program is a very simple program that tries to define declare a structure, and then tries to declare a structure variable and read values into the to the individual members, and then display the individual members, right? Now next is we have a very simple example of a class. So here what we have is we have a class rectangle where we have private members width and held, width and height, and then we have public function set value that takes into integer values, and I have a function area that determines the area of the rectangle. Now to see, it returns an integer. So here the access specifier associated with width and height is private by default. Okay, so now here set value is a function that sets the value of the width and height, and area will return the area of the rectangle. So now since these are private members, what we cannot do is we cannot have direct access to it, so we can access it using the member functions, right? So now I'm defining the function outside the class. So set value is defined outside the class. So I'm providing x and y to set value. So x and y is getting initialized to width and height. Then I am defining my main function. So rectangle. So I have two objects of type rectangle, rect and rect b, right? So I'm setting the values for rect. I'm setting the values for rect b. So I cannot write rect dot width and rect dot height because I do not have direct access to it because it's a private member. So I am doing it through the member function, that is set value. So now the values are set to 3 and 4. So width and height of rect is set to 3 and 4, and width and height of rect b is set to 5 and 6. So now what I'm determining is I'm determining the area of these two rectangles. So it will be 12 and 30. So that's the way how it actually works. So since here what we are trying to basically express is that here, since width and height are private members of the class, so private members cannot be directly accessed through the object. So we are using the member functions in order to do that. So set value is a member function that tries to initialize the private member, that is width and height, and that area returns the product of width and height. So this is a very simple program that tries to determine area of a rectangle. Now here we have the same program being reframed where width and height are public members of the class, right? So width and height are placed in the public section of the class. So area is also a public function. So now to see, what we can do is we can individually assign the width and height to the members of rect1 and rect2. So rect1 and rect2 are objects of class rectangle where width and height can be individually assigned with values. So 5 and 6 is assigned to width and height of rect1, and 7 and 8 is assigned to width and height of rect2. So now I'm determining the area, so it will give me 30 and 56. So you see, this is the way how what we can do is we can access the private members and we can access the public members. So whenever we have to access the private member, then we have to do it using member function. Whenever we access the public member, what we can do is we can directly set the values. Okay, right? As in this case. Now this is what we've discussed about. So here, whenever we try to assign values to the private member, so this would give me an error stating that I do not have an access. So if you run program number 36, right, you will find that the program will provide you an error stating that you cannot have a direct access to the private members. So program number 36 will give you an error. Now, likewise, in this class, what we'll learn about is we have learned about the third case in which what we cannot do is we cannot use function overloading, and then we have learned about overloading of functions with the help of an example where we have 6 instances of add that are capable of performing different operations or capable of adding different numbers based on the number and type of parameters. And then what we have is we have an example for structure being discussed, and we have discussed an example for class. We have discussed the significance of public access specifier, and we have discussed the significance of private access specifier. So thank you very much. Have a good day.